my channel. This is Nice Monkey Science.
This video covers one of the types of chemical bonds that you need to know for GCSE science. It covers ionic bonds. The other type of bonds you need to know about are covalent and metallic. Please see my video on chemical bonds if you want to brush up on this. Ionic bonds are formed from oppositely charged ions, and they consist of metals and non-metals. So let's look at an example. First we're going to focus on lithium over here. It's on the left hand side of the periodic table. So it is a metal. In fact, there's a key here telling us. And it's going to be bonding with chlorine over here in group 7, and you can see from the key that it's a non-metal. Here is a lithium atom. It has a mass number of 7, so it has 7 particles in the nucleus. It also has an atomic number of 3, meaning it has 1, 2, 3 protons, and therefore the atom itself has 3 electrons whizzing around the outside too. Those electrons are arranged as follows: 2 on the inner orbit and 1 whizzing around the outside, and we write it as follows: 2, 1. So that means 2 electrons in the first shell or orbit and 1 in the outside shell or orbit. This can also be drawn as follows, with the chemical symbol and a little dot next to it. That shows there's 1 electron in the outside shell. Now if we move on to chlorine, Cl, we've got 2 electrons in the first shell, 8 in the second, and 7 in the outer shell. So it has an atomic number of 17. So how would we write that? Did you guess correctly? 2, 8, 7. There's the 2, there's the 8, and there's the 7. And in a similar fashion to lithium, we draw the outside electrons around the chemical symbol. This time though we're using crosses. So there's the 2 here, 4, 6, and there's the 7th. So you can see there is a gap here for a full outer shell to be made. As previously mentioned, with ionic bonding, oppositely charged ions attract. So at the moment we've got atoms. These are both atoms. And what happens is the lithium, the metals, want to have a full outer shell, as does chlorine, but it's got 1 electron on the outside shell here that it readily gives up, it readily loses it. So as shown here, the electron gets lost, the arrow moving away. Because chlorine has got 7 electrons in the outside shell, the electron from the outside shell of the metal gets readily accepted by this non-metal. Group 1 easily loses its outside electron, and group 7 easily accepts an extra electron. We can show this in diagram form by removing the dot here and placing the dot here next to chlorine. And then to properly write it out, you put a square bracket around the elements and you show the charge. Now because lithium has lost a negative electron, I like to think of it as it's pushed away negativity. Pushing away negativity makes it feel more positive. It's lost a negative charge, and if you look here, it will have still got its 3 positives, but because it's lost this outside electron, it's only got 2 negatives, so it has overall more positives. It is positively charged. Now because the chlorine has 18 electrons, 18 negative charges around the nucleus, and only has a proton number of 17, is going to be overall negative. It has 1 more electron than protons. So we write a negative sign here. So we've looked at what happens with a group 1 metal with 1 electron in its outside shell. Let's look at the next group. So if we look at this periodic table, if we use beryllium as an example that's in group 2, it has 2 electrons in its outside shell that it readily loses, therefore it becomes a 2 plus ion because it readily gives away 2 electrons. So it becomes positively charged by 2. In addition to this, it's good to remember that the metals will make the positive charges when they bond with the non-metals over here. You've been watching Nice Monkey Science. Please like, subscribe, click the bell for notifications. I'd love to get your comments below.